Hello, geometry people. Today we're going to talk about the trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. And here's a diagram of a trapezoid. The arrows on those two sides indicate those two are the ones that are parallel. The sides that are parallel are called the bases. A trapezoid actually has two bases, and the non-parallel sides are called legs. Excuse me. There's a special kind of trapezoid called an isosceles trapezoid where the legs are equal, but for today we're just going to talk about the regular trapezoid. I just want to contrast the trapezoid with the parallelogram, which has two pair of parallel sides. And you can tell by the arrows I marked the top and bottom and the left and right parallel. Trapezoid has only one pair of parallel sides. Now, to demonstrate one of the properties of a trapezoid, I want to switch back for a while to, if you recall, parallel lines cut by a transversal. They're the parallel lines, and that third line that crosses them is the transversal. These two angles that I have marked with an arc are interior angles on the same side of the transversal. And they are supplementary, which means they add up to 180 degrees. So we're going to take this diagram and transfer it over to the trapezoid. Because what we end up getting here is a trapezoid, or at least one end of the trapezoid. So on a trapezoid, these two angles here along the legs are supplementary. They add up to 180. Also, these two over here would add up to 180. So in a trapezoid, the angles along the legs are supplementary. So let's have a trapezoid. Let's say this angle is 60 and this angle is 130. Well, we can find the other angles because these angles right here add up to 180. So over here, if I do 180 minus 60, I get 120. That angle is 120. And then over here for this angle, I'll do the same thing, 180 minus 130, and I get 50. Okay? So that's really the only property we have of a trapezoid, is that the angles along the legs are supplementary. Now, since it's a quadrilateral, all quadrilaterals, the angles add up to 360, and these also add up to 360. We can get problems a little more involved than the one we just did. Here's another trapezoid, and let me draw a diagonal. Let me say this angle is 25. This angle is 105. Let's find this angle here, which I'm going to call angle 1, and this angle here, which I'm going to call angle 2. Well, the angle up here, when I put these two together, that is the angle in the trapezoid. So that angle right there measures 105 plus 25, which is 130. And now, since we know that angle is 130, we can find angle 1, because angle 1 and 130 are supplementary. So just like we did over here, angle 1 is going to equal 50. Because 130 and 50 makes 180. Now, how are we going to get angle 2? Because I have nothing up here. However, what we do have is a triangle. and we have two of the angles, 105 and 50. We know that the three angles of a triangle always add up to 180. So if I take the 105 and 50, I get 155. So if I subtract that from 180, I get 25 for angle 2. And guess what also happened? If we think of these two parallel lines, and we think this as a transversal right there, this angle and that angle are the alternate interior angles. So this is 25. We knew right away that was 25 also. Lots of times in geometry, there's only one way to solve these problems. And you'll find that in this case too. So that ends our little lesson, our little introductory lesson on trapezoids.